Okay, so what are we here to do? We're here to learn how to do computer programming, right? Intro to computer programming is the name of the class. So there are certain problems out there that computers are really good at solving. There's other problems that they're not so good at solving. We'll ignore those. And when we're trying to solve a problem with a computer, what they say is we're developing algorithms. It's just a fancy word. Like you can think of it as a recipe for making a cake is an algorithm. It's just a set of steps that solve some problem. If you want to use it in a bigger sense, that includes the testing required to make sure that it's working, fixing any bugs that you find while you're testing, continuing to iterate, adding more functionality, making it more complex, continuing to fix bugs until you have something that you're happy with, you want to ship. I would say that you want to learn that software development in general, computer programming in particular, is more of what you would think of as a lifelong skill. When you think of it from the point of view of just teaching it, I've not gone more than 2 years with the same textbook. So we have to keep changing the textbook every couple of years because the technology keeps changing underneath us, and we have to keep teaching the new stuff. If you take a class and the textbook is 5, 7, 10 years old in the computer science area, I'd be asking the teacher how relevant this material is, because it's probably not as much. I mean, there's exceptions, but that's just one of the things about our industry is you have to be prepared to continually be learning new stuff. Even things that have been around for a while, they keep changing all the time and improving. Somebody will create, we were talking in my last class, there's this new language called Rust. And because of some of the things that people are doing with Rust, it's causing changes to the C# language, because the people that do C# programming want to take advantage of some of those new ideas. So there's a lot of cross-pollination between software teams that happens. So just be ready for that. You can't just learn it and be done. My wife is a software developer, or has been one. She started out her career that way anyway, and she learned COBOL. I'm sure some of you have heard of COBOL language. It was a language used by business software developers 30 years ago. Actually, if you go like to Indeed.com and search for COBOL, there's still people that hire COBOL programmers, even though it's like an ancient language. So there's exceptions, but most people just, take it for granted that you're going to have to continue learning new stuff year after year after year. So I've had a lot of fun. I've done some really fun projects in my career, had some good opportunities, and it's typically a good paying job. So I say typically, historically that's been true. I think there are some people that want to try to turn it into more of a minimum wage type of a job, which is unfortunate. They want to make it repetitive and redundant and mundane and tedious, and I don't like those trends because I see programming as a creative, artistic endeavor. The computer is our canvas, and we're typing and creating artistic, creative works into the computer to do new and cool things. So that's my view of it. So hopefully that will happen. And I guess an example of what I'm talking about is if you want to be a web page developer, it's a fun thing to do. There's people that are really good at it and enjoy it, especially if you have more of a graphic arts type focus. But you have to be very efficient at it. Unless you're somebody that's pumping out a couple of websites per week, it's going to be really hard to be competitive and make more than minimum wage doing it. You work a lot of hours, you produce a lot of HTML, and you won't get paid very much. So the trick is in that field to be very efficient, to make yourself very scalable, do a lot of copying and pasting, a lot of repeating the same patterns over and over again. That's an example. I like more things like designing video games and building multi-tiered platforms for e-commerce and stuff like that, that is more interesting and more complicated and pays more because there's fewer and fewer people that do it. Just as an aside, I've had conversations over the years with people that are big proponents of open source software. And I caution them to say, you know, there's this attitude, like, especially if you're very skilled and you realize, man, this stuff is just clicking. I'm really good at this programming stuff, to think that it's easy and therefore not worth very much. But every one of these classes that you take, you know, you add another programming language, you learn database development, you learn web development, you add these skills to your tool belt, that makes you more of a rare talent in the industry. You know, there's still a lot of people that have those, because obviously this is, you know, the beginning of your career, not the end of it. But the more refined your skills get, and the more specialized you are, and the more experience you get, the more valuable your time should become. Just like any, like even plumbers and electricians should be that way too. The more experience they get, the more valuable their time should be. So don't sell yourself short by just giving it away for free. You know, realize what you're worth and demand it, and don't help everybody. So I put this in here. Programming is different than creating web pages. It's just, you know, when you learn both, you realize, oh yeah, HTML and stuff is not really a programming language. It's just kind of different. It's more than playing games, and I say that because I hear frequently that somebody really enjoys playing Call of Duty and they're spending a lot of time on the computer, and their parents are like, you know, you spend so much time on the computer, you should go do something in computers. And so they come and they take programming classes, and it's like, this isn't playing games. This isn't what I enjoy doing. So it's more than just playing games. I mean, you could create the games if you get skilled enough. It is going to be easier than it may seem at first. There's some tricks that you have to learn. You have to kind of get your brain to think more like the computer in some ways. And it's much deeper and much broader and much harder than we can master in just one semester. So just be ready for that. This is hopefully an intro to teach the patterns and the tricks, and then hopefully unlock the doors that you can go through to get more and more skills under your belt. Any questions? No? Excellent. Okay, so our objectives for the course, we have to learn some skills. There's a few things that you might have, if you started reading the book already, you might have come across. They talk about all kinds of different kinds of diagrams and decomposition and you know, pseudocoding, flow charting, and these are skills that we're just going to have to learn, because we're probably going to repeat them for a while for every single problem that we look at. Eventually, you get to a point, you know, you get a few years of experience doing these things, and maybe I just jump into the code. Maybe I don't have to write pseudocode for it to start with now, because I've gotten past that. I can basically do my pseudocode in actual code because my brain now thinks in that language. Sort of like, you know, when you speak, you learn to speak Spanish or something, and then you find that you're falling asleep and you dream in Spanish because you know the language so well now. You know, computer languages are similar to spoken languages in that way. Flowcharts are essentially a parallel to the pseudocode. They're just a picture of the flow of it instead of text. So some people prefer one, some people prefer the other. But similar, maybe after a while you'll say, oh yeah, I did the flow chart in my head, so I didn't need to do one on paper, and you'll skip that step after a while. But sometimes in here, I will artificially tell you, no, I want you to turn in the pseudocode. I want you to turn in the flow chart, because I just want to see that you're able to do it. Because even if you eventually get to a point where you skip it, you will be reading pseudocode, you'll be reading flow charts when you get out in the industry, and you'll need to understand what they mean and what they're saying. So we have the skill of taking a problem, decomposing it, as the book would say, and developing a solution or algorithm for it. And so this term called system analyst, you might have heard in the video, you know, that's what one of my early teachers told me, hey, what are you going to be when you grow up? you're going to be a system analyst, and I didn't know what it meant. But we are often called system analysts because that's what we do. You get into this habit of, you'll be standing there in line to get into a concert or something, and you'll say, you know, they're not load balancing their lines very well. If they had, you know, another Pepsi machine over here on this table, then the load would shift and make it asynchronously shift. And you just start thinking about that way when you're observing these systems in practice. Or you see a flock of birds flying along, and two of the birds, you look at them, one of them turns this way and the other one turns that way a millisecond later, and you think, wow, what is the logic of each bird using that causes them to behave as a flock like that? You know, and realize, oh, that's what they're talking about when they say swarm theory, and you know, all that individual logic causing emergent behavior in large groups of agents, stuff like that. So you'll just start thinking about large systems and complicated systems and how to break the logic down into smaller components. I'll show you this video real quick. This is just something dumb that I put together. So this is kind of what we're going to be targeting a lot in here. Simple console applications written in Python. You create a Python program in a py file. You run it from the command line. You know, it supports some different options. You can type in some text. It accepts the text. It prompts you for the next thing. You enter that. You know, after the zip code, then it says, okay, it gives you some kind of output. Then you pick the next option, and then after a while, you type in an X and it exits. That's just a quick, dumb little example of what our goal here is, at least initially. And I put that in there. I know it's not much, but a lot of people are like, hey, what's the point of this? I don't understand what we're doing. So think of that as your goal, at least initially. As far as the whole semester 50,000 foot view, no matter what programming language that you want to learn, Python included, there's a general flow, some variations, but generally you're going to hit all these topics before you can say, oh, okay, I've been introduced to that programming language. So first of all, you're going to have to understand the basic part of what is a computer program, what does it need to be able to do its job, inputs, processes, outputs, how does it manage the memory to store all these values that it's messing with. You have to be able, this is where the flow chart and the pseudocode come in. Once you say, hey, I think I've got an idea for how to implement this program, you have to be able to communicate that to somebody else. And until we, you know, master the whole telepathy thing or Elon's brain chips, we use paper. So flowchart and pseudocode will be our defaults here. After a while, you'll start to recognize common design patterns. Like many of our assignments, you'll be able to start and copy and paste some of the logic because, for example, many of these projects will say, keep asking for input until the user enters the word quit. Or like the example I showed, I put the X in there and I hit enter, and my program said, oh, you said X, so I'm going to stop repeating and I'm going to exit the program. That's a common pattern that we'll put into a lot of our programs. And it just makes it more convenient for you to test it. You don't have to keep typing Python myprogram.py every time you want to test it. It'll just keep running and keep looping until you say, okay, I'm done with that now. So testing, there's some common practices to learn with testing your program that we can talk about. And then we get into these. So we need to learn what a variable is. We need to learn how we assign values to variables, how we use those variables and the values that they contain in different computations and calculations. And then conditional logic, that's if then else. You know, if the value that's in this variable is greater than 5, we're going to do one thing. If it's not, we're going to do something else. We talked a little bit about Boolean logic, truth tables, stuff like that. Repetition I mentioned. We'll talk then about modular programming, because once you program something, it becomes sort of a black box. It's got defined inputs and defined outputs, and you can reuse that in other programs. Recursion is a variation of repetition where you have one of these programs and it calls itself. That's basically what recursion is. And then libraries. So once you're out trying to do more complex programs, you'll realize people have built libraries of these little black boxes of stuff that do useful things, like math libraries. So you don't have to solve some of these problems. They've already written it. All you have to do is call their function in their library to do that work. So those are very helpful. And they'll do a lot of this out on the job because nobody wants to pay you to reinvent the wheel. If they've already paid some other developer to write this program, they want you to use most of that work or reuse it so they don't have to pay for it to be written again. I used to say you could make a fortune if you wait until some new technology comes out and re-implement Ms. Pac-Man in that technology. Because for a while there, that was all it was. Oh, Windows 7 changes to Windows 8. Well, we need Pac-Man to run on Windows 8, so somebody would go out and implement it, and then they could sell it. People were making a lot of money off that kind of stuff. Any questions at this point? Okay. I promised to only talk for half the class, so I'll stick to that. And these PowerPoints should be in Canvas as of just before class. So go. I've been talking too quickly. All right, so what is an algorithm? As I mentioned before, it's just a set of steps that solve some problem. We'll talk about a number of examples tonight. A map, if I give you directions, go down to the end of the block, turn left, go to the T in the road, turn right, go 3 blocks, and your destination is on the right. That's sort of a kind of an algorithm. You get an IKEA thing, get it home, open up the box, and they've got some instructions there. You follow those instructions. That's their algorithm for taking this input, which is this set of parts, and turning it into the output, which is the bookcase. Okay, similar thing, algorithm. Okay, yeah, so how to defuse a bomb? Yes, that's an algorithm. A little bit different consequences there. We got lots of ways to describe algorithms. I like throwing the DNA example out there. Our DNA is this big, huge, long algorithm that tells our body how to build and repair itself. A sketch, okay. I could see in a sense how a sketch could be how you communicate what somebody else looks like, how to identify them. That could be considered a form of an algorithm. Or our handy map down here with all the instructions where to find the treasure. This is a key point that people often miss is these flowcharts and pseudocodes and other kinds of diagrams that the book's going to talk about. This is all meant for human-to-human communication. We're not going to take a flowchart and stick it in there and tell it to give us our Python code. You're not going to turn in your flowchart to your boss and they're going to say, okay, good job, here's your paycheck. This is just for us when we get in a meeting to explain within our team or to developer to developer what I had in mind for how to solve this problem. So there's a difference when we start talking about what we turn in for the assignment that often gets kind of confusing. It's like, well, do you want me to turn in the flowchart or do you want me to turn in the Python code? There are people that take this class, many of you might be in a situation that maybe in high school or some other school or before, you've already had a Python programming course. That's not uncommon. And so I get people that are like, well, I don't need to do the flowchart or the pseudocode. I'll just turn in my Python code and that counts as everything. Well, sort of, except that I need to know that you can do the flowchart and pseudocode before we can get to that step. So if it, just pay attention to the assignment. If it says turn in a flow chart, or if it says turn in pseudocode, do that. If it doesn't say that you have to turn those in, I still encourage you to think about doing it, because here's what happens. I'll get somebody's program and they'll have gotten way off track and really complicated and has a bunch of bugs in it, and I don't understand what they meant to do with this program. And if they also turned in a flow chart, I can kind of follow through there and say, oh, okay, I see what you're doing. Yeah, this code doesn't do this. And I can figure out how to guide you to fixing it. It's just like supporting material. So, because, you know, I'm a human, you're communicating to the human about the intentions of your algorithm. Yeah, and if I gave two of you the same flow chart, I would expect the two of you to produce similar Python code, because you're using the same approach outlined in the flow chart. That's another way that these tools are useful. Yeah, these take many forms. We've got some really interesting tools available nowadays. In previous semesters, we were using a tool called Raptor, which it was okay, but has some limitations. I really like Flowgorithm a lot better. It does a similar thing, has a little prettier user interface, and just works better. So I'm going to ask that you try to use Flowgorithm, even if you're familiar with Raptor from previous semester or previous classes on it. Visio is okay, but it's really kind of old school. Doesn't have some of the features that these other tools have. And when it comes right down to it, if you're just trying to communicate with another human, again, it doesn't have to be really precise. A napkin would suffice. But here's kind of what one looks like. That's probably too strong or too small to read. But it's got, this is a conditional. So these ovals are a start. You always start where the oval is. These do some kind of an operation. This says, hey, if something's true, go this way. If something's false, go this way. If it's this or this. And then it comes down here, another oval says that's the end. Flowcharts always go from top to bottom if they're correct. I've had teachers that were very strict on that, and I'm like, well, yeah, but my paper ends here, so I'm going to go over here and up and have my oval there to end the program. They're like, no, can't do that. Get a bigger piece of paper or think ahead. Anyway, so we'll play with those. The other thing I would point out is that last point there. In general, the earlier a bug is found, the easier or cheaper it is to fix. Has always been said. There's notable exceptions to that, but generally that's true. So if you can write a flow chart and figure out that your logic isn't really holding together before you start coding, then it's easier. I have been on projects where people though thought that if they did enough documentation, enough flow charting and pseudocoding, that the system would just magically wake up overnight and become sentient. It doesn't work that way. At some point, you just got to stop thinking about the problem and just go over and start writing the code. So it can be a balance too. Another point is, you know, is this supposed to be perfect? No. Pseudocode is allowed to be less precise. It can assume some things, because again, we're humans. We're talking to other humans here with the flowchart and pseudocode. So if we take some liberties with it, it's generally okay. But I'm still going to grade it because that's the point of it. I want to make sure that you know what it should look like, so that you don't misunderstand that it's okay to do those kind of things. So lots of examples. So if you're asked to produce both of them in an assignment, make both of them. And I would say that this is, you know, similar. Another way to look at this is like if you're taking an English class and they make you write a research paper, they're probably going to have you turn in a first draft and then a second draft. You're going to add citations. You're going to continue building it up until you get to the final product. The flow chart and pseudocode are similar to that. You're getting your thoughts together, you're thinking it through, making sure that it makes sense. Maybe you throw it away and start over, try another approach until you're pretty confident in it. That's your rough draft, and then you go on to the final product. Okay, so here's our first example. If the problem is go to the store, is that a good algorithm or a bad algorithm, would you say? Okay, why? Okay, so what I hear you saying is we're taking some liberties and we're making some assumptions there, right? What are the inputs? What do I need to know? What do I need to have before I go to the store? It doesn't say, right? But we as humans, we know, well, I'm probably going to need to grab the store list. I'm probably going to need my credit card or checkbook or some cash. I'm probably going to need to know which store. Are we going grocery shopping? Are we going clothes shopping, right? So there's a lot of assumptions there. Again, we as humans, we're pretty good about interpreting context. If my wife is standing in the kitchen and she says, hey, go to the store, she's probably making something and she probably realized she's out of it and she needs me to very quickly respond and go to the grocery store to get the 1 or 2 items that she needs. Anything else I can quickly pick up. I can infer all of that context. But if we're doing an algorithm, we're going to need more information. So the outputs, probably some bags of groceries, right? But it doesn't say. It assumes you know that that's what your goal is. The processing step, it assumes that we know that we're going to have to get in the car. We're going to have to follow some instructions, some directions to get there, to get back home, how to operate while we're in the store, which aisles to go down. I mean, there's a lot assumed there. Dependencies. What would it depend? Well, the car needs to have fuel in it. I'm expecting that. I'm assuming that that's understood by everybody that, well, yeah, the car has to be working, it has to have fuel in it. So yeah, I would probably say that that's not enough. What do we do with that? Do we say, no, I can't work on that assignment because it's not a good algorithm? Well, maybe sometimes, but generally, if your boss gives you that algorithm and tells you to solve that problem, you're going to have to make some assumptions. You're going to have to do the best you can, and you're probably still going to get yelled at when you screw up. But yeah, for the sake of argument, yeah, we would say that algorithm's got a bunch of problems with it. Okay, this one seems a little bit more computerish, maybe a little bit more what we're talking about, right? Add 2 numbers together and print the result. So it's better. Would you call that a good algorithm? Right. If it has any deficiencies that you can point out, what would you say they are?
Limitations, like add 2 numbers, single-digit numbers, and then print the result.
Yeah, what kind of numbers? Yeah, excellent. So yeah, we know what our 2 inputs are. It was good about saying that 2 numbers, but a little vague. We're going to have to make some assumptions about, decimal numbers or just integers, dollar values. What are we talking about here? Print the result. Okay, same thing. If these are dollar values, we're probably going to have to put a $sign in front of it. If it's decimal numbers, we're probably going to have to put the period and the numbers after the decimal point. So there might be some value to knowing a little bit more precisely what you mean by printing the result. Processing steps, probably got all we need there, right? We all understand addition, so that's probably fine. Not many dependencies, the 4 stated assumptions, but better. We're getting there. Okay, calculate the distance between 2 points. Yeah. Right.
like on a graph in physics.
Yeah. What do we know about the 2 points? Are we given 2 street addresses? That's gonna probably require us to use a whole bunch of different information to calculate the distance. Are we given 2 GPS coordinates? Is it a geometry problem? Are we given 2 XY coordinates? You know, if
The
there's,
shortest distance or any distance between the 2 points.
that's a good point too. I don't know if any of you've done this math before, but like there's if you're calculating the distance between 2 points on the globe, you have to take into consideration what rotation value, because you can go this way and get there, you can go that way and get there, or you can go straight across. You know, there's ways to calculate that that are very subtle. So yeah, we've got probably, this is worse than the previous example. We've got more things that were not clear about this one. And then how do you want it output? It doesn't say what to do with it. Okay, I calculated the distance, done. I didn't have to output it at all. It's making some assumptions about how we're expected to print that. So we can often not reject it out of hand and say, I can't do this problem because you haven't given me enough information. But the technique that we learn in software development is, may I ask some clarifying questions? What format are the 2 points going to be defined as? How would you like the output formatted? What units should I use? Is there a special way that you would like me to calculate the distance? We can ask some of those clarifying questions to reduce the risk that we're going to do it wrong. Any questions about that one? Okay, so I'll produce pseudocode to set a variable to 5 and another one to 12, add the variables together, store it in a third variable, display a message that announces what follows will be the sum of 5 and 12, then display the contents of the third variable. No assumptions, very clear, and your boss will hardly ever give you this clear instructions. So, but that's, you know, the gold standard there. We know exactly what our inputs are going to be. Okay, yeah. We don't know the type of the variable, decimal or integer, but the 2 example pieces of data we were given are integer, so we can probably safely assume that. Yeah, very explicit. So, yes. This is another point that I seem to be putting these little points off of there in the small print, but I'll call that out too. Sometimes you can infer too much just because, like if you're used to working on geometry and somebody comes to you with a math problem, you might assume that they're coming to you because that's what it's going to be, is that kind of a problem. Like if you're a plumber and somebody calls you on the phone, you may assume that they want you to solve a plumbing issue, then they're not going to ask you an electrical issue. So all I'm saying here with this is have caution about, you know, make sure you still ask clarifying questions to make sure that you're not making any invalid assumptions. Assumptions are okay as long as they're correct. Okay, so let's do one. And this is probably a little premature because I realize most of you probably haven't read the whole first chapter and dug into this yet to get all the gist of the of what the book's going to be talking about. Let's see. Yeah, this is the last one. So get 2 numbers from the user, add them together, and print the result. And we're going to do the flow chart, the pseudocode, and the Python, and then talk about what we turn in. So I will, well, let me continue to have this up because I want to go through and show you at least an example so you've seen it once of what we're going to typically do in the class, okay? All right, so we have these software packages on our computer. One of them is called Fun. Okay, there's Funny, no big deal. It looks kind of like Notepad, right? But it's Notepad for Python programs. Very simple, but we'll see, it's got some cool features. Then we've got this other one called Flowgorithm. It looks kind of nifty. And it's got some cool features too. All your computers should have that on there. What was the first option? The first one is called Thonny, Thonny. I have no idea where they came up with the name. TH, right? TH, yeah. And there might be a shortcut on your desktop for it. It would look like this, just this little TH.
Are we supposed to download this to our computers too?
If you are working on your computer at home and you find this useful, which many of you may find this useful, yes, I would suggest that you download it and install it. And there should be instructions in Canvas on getting started with this, a video from YouTube that goes through an example like I'm going to be going through, and lots of other stuff. Like I said, this might be a little premature, so don't let me blow you away just because, oh, what the heck are you talking about here? This is way too advanced. Just take your time, file it away, read the first chapter of the book, watch the videos in Canvas, and try to do the assignments.
The book is online or is it?
The book? Yeah. The book should have links in Canvas to it. Look in the syllabus, it has the reference to the textbook, and the book should be in Cengage.
We have to make an account with
I believe so, yeah. You probably have to purchase that textbook from the bookstore and they'll give you some kind of activation steps or something.
So I have the flow chart, just not Thonny.
It has what?
This computer has flow chart, but it does not have Thonny.
Interesting. Okay, does anybody else not have Thonny on their computer?
Search for it.
I searched on files. So
I'm trying to search for files.
Put the start menu, and just type fun.
oh, that works. Thank you.
Excellent. Okay, so back up here. Okay, so the problem was get two numbers from the user, add them together, and print the result. So one of the other things that we'll be doing in here, in addition to learning how to flow chart with these tools and learning how to pseudocode and stuff, is actually learning the Python programming language. And the beginnings of that are in chapter 1 in the textbook, chapter 2 in the textbook. There are reference materials on Canvas that are linked there, PDF files that have some of the commands that I'm going to be demonstrating. So hopefully there's lots of information out there in Canvas to get you going. Just like I said, don't let me blow you away if you haven't seen what I'm presenting now. Don't think that you should have already known that by the time you got here tonight. I'm just trying to show you in advance of when you try it yourself, you'll say, oh yeah, I saw him do that in class. Okay, we're going to get two numbers from the user. So in Python, we would say input number 1. Okay, so this is using a command. Let's see if I can make this bigger. Perfect. That all readable? Okay, so X and Y are numbers that I invented out of my head to represent the name of variables. So when we're talking about programming and we use the word variable, think of that as a bucket. And buckets can have different sizes and shapes depending on what data type we're going to be using and putting in them, but it's just a bucket. So I have two buckets, one bucket named X and one bucket named Y. So the first statement is going to put something into or assign a value to the bucket named X. In Python, to do that, we use an input statement. That's what that input keyword is. And in parentheses after it, I can put in double quotes what I want the computer to print on the screen before they retrieve the value and return it. I'm going to do that twice, once to get the first value and once to get the second value. It'll execute the statements in order from top to bottom. And at the end of this, have I printed anything to the screen? Have I done any computation steps? No. All I've done is I've said, hey, give me those two numbers and exit. Anytime I want to, I can just run this. And down here on the bottom, you can see it. It shows what the computer is doing. So I can say 5, enter, 12, enter, and then it exits. It goes back to this. So it didn't really do anything useful, but it did ask the user for the first number and get the value and put it into X, ask for the second number, got the value back and put it in Y. And that's all I asked it to do at this point. Okay. Now I can add the two numbers together. I'm going to do this wrong to start with, just to show you. Okay, so I added the two numbers together. That says take the value in bucket X, the value in bucket Y, add them together.
We have to leave the nth line between them.
Well, we have to do something with the value, right? So it's going to add them together. 5 plus 12, 17. But it's not going to do anything with the result, right? It just says, okay, 5 plus 12. So I need to do something with that. So I can say Z equals X plus Y. Now I'm saying add buckets X and Y together and take that value that's a result and put it into a new bucket called Z. Now I've got 3 buckets, X, Y, and Z. They all have a value in them. So a couple of other points to observe here. I'm going to run the program again. So it starts over down at the bottom. It displays my first prompt, enter number 1. I don't have to use 5 and 12. I can say 27. Now, at this point, the bucket called X has 27 in it. The buckets Y and Z, what do they have in them? Nothing yet, or at least we don't know. They probably have some value in them, but we don't know what that value is. It's not useful because it's not deterministic. We haven't been intentional about what we want those buckets to contain at this point. So they're just question marks. We don't know what's in them. Okay, this time I can enter 31, let's say, hit enter. Okay, so similar output to last time. It didn't really do anything, right? It didn't print anything. I have to just trust that it added 27 and 31 together and put the output into the bucket called Z. But it didn't do anything with Z. But now, I'll go up here and I'll use another keyword, print Z. I'm going to run it again. Oops. My bad. I'll do this a lot, I'm sure. I have to put that in parentheses. Okay, enter number 1, 27, 31. And so this is interesting. It printed 2731. Okay, some of you I see grinning, you probably understand what went wrong there, right? Right, 27 and 31, it in a sense added them together. But the problem is it did a string add. So this is one of the things about computer programming that you have to recognize. You have to think a little bit more abstractly. This plus sign is an operator. The operator plus sign in Python has very strict definition of what it does. If I give it 2 operands, it's an operator and it has 2 operands. But those operands are text strings, then it's going to concatenate them instead of adding the numbers together. And I was not explicit about my instructions. Okay, so now I have to learn a new keyword. This whole thing here, it returns a string. So I can do this a couple of different ways, and this is where it becomes kind of stylistic. You can do things your own way. You have options. I could say XX equals int of x. So what that keyword, that operator does in Python is it takes the string, the bucket called x that contains character data, and says convert what's in that to a number and put it into another bucket called XX. And I'm just making up these variable names as I go. They're fairly arbitrary. And then I could do the same thing for this. Anybody see what I did wrong? Got X in there twice. Right? I meant to say Y. So that's why we test early and often. Well, let me leave that as X for just a moment and see what happens. Enter number 1, 5. Enter number 2, 12. 5, 1, 2. Well, wait a minute. What's going on here? Didn't I just convert those to numbers? I did, but I didn't change what I do down here. I meant to add together XX and YY. So that was a bug. I fixed the bug. I tried again. Enter number 1, 5. Number 2, 12. Now I get 10. Wait, that's not 5 plus 12. It's because I converted X both times. So I put a 5 into XX and a 5 into YY. I added 5 plus 5, and I got 10 instead of what I wanted. So I find my bug. I meant to type Y. I'll run it again. 5, 12, and voila, I get 17. So you see how this is iterative, and you didn't. I used to be a tester at Microsoft for a while, and I went to this little conference. There was a bunch of testers talking about testing from their own teams, talking about their challenges with testing and stuff. And one guy stood up and he was talking about, I can't believe how many bugs my developers write. And then I have to go find them and report bugs and have them fix them. It's just amazing how many bugs they create. I got curious. I thought, I wonder how many bugs I create. And so I kept a little post-it there on my note. on my desk with a pencil. And every time I did something like that, I just put a little tick mark on the piece of paper. And I just did that for a day or two. And then I went back and thought, you know, I just wrote a program that's 8 lines of code, you know, counting this, the blank lines and stuff. And I just made, what, 5 mistakes in 8 lines of code? I started realizing my own error rate was about 1 bug per line of code. So, okay, maybe I can give my developers a break. So it's typical, expected. Another thing I'll point out is when you make errors like that, kind of keep a mental note of that. Because what I've seen is developers tend to make the same kind of mistakes over and over again. And your list is going to be different than the person sitting next to you. The person sitting next to you, they may make a completely different kind of error and not the kind of error that you make. And you'll want to start learning these tendencies that you have and use that kind of as a mental checklist before you go turn in your program. Say, oh, did I do this? Did I do this? Did I do this? And go back and check your code before you say I'm done. You'll catch a bunch of stuff. And it'll be particular to your work. So this is a basic program that does what we set out to do, right? So excellent. Yeah.
Is there a way to make the input just immediately become an integer, or does it have to go through that?
Yes. So that's where I said it becomes kind of a style thing. You can combine these things. Oops. So like I could wrap this whole thing in that command. And now I deleted a line of code. It looks a little cleaner. Now, if I run it, I know I already made this mistake before. So instead of leaving this YY, I'm going to change it to Y. So I made this change. So I'm going to go ahead and make this change. Somebody else may say, well, wait a minute. YY was better because it was the numeric version of that variable. So I'm going to leave it like this, you know. Maybe some people will do it one way, some people will do it the other. I can even go do the other one that way too. There. So looks a lot cleaner, right? Fewer lines of code. Let's see if it runs. 8, 6, 14. Yeah, great, it worked. This isn't really, I mean, that was basically the conclusion of the demonstration I was hoping to make, but I would probably do some other stuff here. Why is my turning a different color? Comments not slash.
It has to be the.
Oh, that's right.
For some reason.
Sorry, I programmed in too many languages. Okay.
I also did the //
Different languages use different things for comments. But often you'll work on a program and then you'll leave it for a week and you'll come back and it's like, what the heck is this code even doing? So putting a couple of comments up here at the top is very helpful. I would even maybe go further. Get first number, right? I promise not to count off on any of your assignments because you put in too many comments. Now that's looking really nice, I think. Does the exact same thing, it just looks prettier now. I can also come up here and make my prompt better. Please enter first number. And did you know how notice how down here there's no space between the prompt and the value? I don't like that, so I'm going to clean it up a little bit. Please enter first number, colon space. Thanks. Please enter number 2. Colon space. And I'm also going to do something really radical down here. I'm going to say the sum of those 2 numbers is. Let's see what this one does when I run it. Please enter first number 6. Thanks. Please enter number 2. 9. Uh-oh. So what did I do wrong?
It's sort of quilt over there.
Remember how when I got the value from this input statement, it returned character data and I had to convert it to integer? I had the opposite issue going on here. Remember what this plus sign does when it has character data? It concatenates them together, except that one of these is a character string, the other one is a number, and it says, I don't know what you want me to do with this. Has anybody seen in the book what to do with that? Like that? You think? We're going to type to a string. Okay, let's write it again. 6, 9, 10. Victory. So if you were to turn that in for your Python, I'd say beautiful, excellent. It's got comments, it's got nice, precise prompts. Does exactly what it's supposed to do. Excellent job. Okay. Like I said, I know I don't expect any of you to know how to do that when you show up to class today, but now you've seen an example of it. Okay, so let's switch over to this flowchart thing. Same problem. Get 2 numbers, add them together, print the result. Yeah. You don't have Flowgorithm on your computer? This is what the shortcut looks like. This thing. Or you can hit the start button and type FLOW, and hopefully it'll show up in the list. Yeah.
Quick question. How would you say for us, like, remember, like, the commands and stuff, like, the best way to remember the commands and stuff?
The commands that I used in this program.
Yeah.
So you'll have a PDF file in Canvas that has a quick shortcut list of a bunch of the commands and stuff that you can do. So print that or download it, make sure you got that handy somewhere. And then also the book. The book is basically a textbook on how to write Python. So as you start reading chapter 1, you'll run across some of these things. Chapter 2, you'll get more. Yeah, you just continue to add them to your tool belt and say, oh, wow, I didn't know you could do that. Like, you know, if you want to print dollar amounts, we're going to see how to format your output so that it puts the dollar sign and the decimal points and things like that in there automatically for you. There's some really cool stuff.
Yeah, because I haven't programmed like since high school, so I don't remember anything.
Yeah, that's exactly why we're here. Yeah.
So do I have to download Python, or are we gonna be turning in stuff through the Honey and Flowgorithm?
Okay, so good question. Before I switch back over to Flowgorithm, so I've got this file in here that I've been typing on. If my computer gets turned off or I close this program, I'm probably just going to lose it, because you notice up there in the left it says untitled asterisk. So I've never saved this file. I've been working on it, I've been running it, I've been working on it, I've been running it, but I've never saved it. So if we want to turn it in, we're going to have to save it. So I click the save button up here, and on my desktop, I'll say, example.py. So all of our Python files are going to be .py file extensions. I say save. So here it is. Now, This is Windows default configuration, so it hides the .py. It uses the .py to change what the icon is, so that it looks like a Python program, but it hides the .py from it. It's still there, it's just hiding it from you, so don't be misled by that. When I look here in Thonny, the .py is still on the file name up there. I know it's tiny, but it's still there. So now I've saved it. I've got it here on my desktop, and this is what I'm going to upload into Canvas to turn in my assignment when it says I want Python code. Okay, any questions?
We just upload the file that we have on the desktop.
What?
The file that we saved on the desktop, we just put it into Canvas, right?
Yep, there'll be an upload button or submit button, and you'll pick that file and upload it. And then I'll get a message that says, hey, you just turned in this assignment. Yeah,
Will you count like the notation in that as the pseudocode, or no, you want that separate?
I was just going to mention that. So pseudocode is even easier. It's kind of a trivial example to illustrate this, but I would just use Notepad. And for an assignment, an example as easy as this, your pseudocode is going to look something like begin. I think that's what the textbook uses as their formatting. Get first number, get second number, add them together, print the result. And there's your pseudocode. Now it's going to get more robust and complicated, but same thing here. I would say file, save, example.txt. Oh, I put it someplace else. So click on desktop, example.txt. Okay, here's my example.txt file. So for my pseudocode, that's what I would upload. And the flowchart, here's my flowgorithm. Let's see, I have to add some stuff in here. And this is again where you're going to have to kind of just learn in the book watching, but we'll talk about input, process, and output diagrams, IPO diagrams. And so most programs have inputs. They use those inputs to do processing, and the result of that processing produces outputs that we put on the screen. And so each of those kind of instructions or statements has a different shape in the flowchart. So the ovals are begin and end. This calls the begin main. Name. It's got features, play with it, see what you like, don't like. But I need to add a symbol to this. Where's the,
Oh, to add something, you just click on the arrow, like from the. Yeah.
okay, yeah, when I put my mouse over and it changes to orange, I click on it. What am I gonna add? And it's a little subtle, so I say input, first number. This is kind of tricky too. Enter variable name, X, input X. Click on this, another input statement, input Y. Now I've got my two inputs. Click on it again, sign, double click on it, Z equals what expression? X plus Y. Okay. Again, output, double click on it, output Z. So this is a basic flow chart that does the same thing that my pseudocode and my Python program do. Zoom in on this. All right. And the cool thing about logarithm is I can hit the play button. Declare. So logarithm makes me say variable names, X, comma, Y, comma, Z. I mean, that's good. That's why we're doing this design work up front. We're identifying all of our variables. So that's why it's telling us to do that. So that works. Okay, it says console, enter a value of type integer for X, 6. Enter. Please enter a value of type integer for Y, 9. Enter. And it outputs 15. So that output is basically doing the exact same thing that this here did, but it's doing it in flowchart form. So then I can close this. And so there's my flowchart.
Professor, can I see how you did Z equals X plus Y? 'Cause
Sure.
I'm getting Z equals Z.
If you double click on it, you say Z, and then over here on the expression, you say what calculation.
Gotcha. Thank you.
Sure. Everybody else with me there? I did that kind of quickly. Skipped over a bunch of stuff. Like I said, there's 2 YouTube videos in there, one for Thonny and one for Flowgorithm, that take their time and they go through that stuff and they tell you how the buttons and stuff work.
We're submitting both or just the body?
When asked. So pay attention to the assignment. If the assignment says submit a flowchart, submit pseudocode, submit the Python file, then you want to do that. Same thing on this one. If I hit the save button, go to my desktop, and I say example. What is it? .fprg for some reason. .fprg. Save it. And so those are the 3 files, my flowchart, my pseudocode, and my Python program.
So, quick question.
Yeah.
So those two, the Thorny and the Flow,
Logarithm.
those are, so we have to download on the, okay.
Yeah, on your own computer, you'll have to download these.
So I just tried, because it's not on this computer at all. I tried to download it.
Really?
Yeah, fly.
Yeah, you don't have, so if that's the case, I'll have to just send IT a thing. Did anybody ever else have that problem with Bonnie and so several of you? Okay, I'll just tell IT department that they have to figure out which machine is this guy. Thank you for letting me know that.
So then we do have to have Python on our computers as well.
I think when you install Bonnie, it comes with a distro of Python, and Windows comes with Python. So like, I'll show you this too. Again, I'm trying not to blow you away, but if you open a command prompt on Windows and you type Python, okay, maybe Python wasn't installed already, fine. Is it gonna let me? Okay, so your mileage may vary on the school computer, but on your own computer, if you just go to a command prompt and type Python, then it'll try to install it if it's not already. I thought it comes by default on Windows 11, so maybe they explicitly removed it. Okay. Python. Okay, so it came up. Now I can say things like X equals 6, Y equals 9. Z equals X plus Y. Let me make this a little bigger. Print Z. Oh, Again. So. All kinds of ways to get there. But, so I didn't show you this one because like if you take this and you copy this and paste it and turn that in, that doesn't help me. That's not a Python program that you're turning in. That's just typing some random Python statements to see what they do. I encourage you to use this because especially if you're reading about new commands in the book and you want to know what they do, just go play around with them. It's not like you can delete windows or anything really destructive just by using the commands that you can do in Python. It's fun. And that's kind of what we're going for, the whole getting comfortable, experimenting, trial and error, debugging, iterating, adding functionality, cleaning it up, improving it, cleaning up the prompts, adding comments. All of those things are part of what we're doing. So 7:30. So I promised I was only going to talk for about half the class, and we're past that now. Is there anything else anybody would like to see on this before you go off and play with it yourself? Fun stuff? Good? Bad? Awesome.
I got a quick question.
Yeah.
What would you say to like any website to use, like in our free time?
So there are some things out there. There are some good resources. Thanks for bringing that up. There's a site called W3 Schools. W3schools.com. And they have a whole unit of their site devoted to Python. As you can see across the top, they have tutorials in all kinds of different technologies, from HTML to C++, lots of stuff. Some stuff that I've never even played with before. Python Home. This is really cool. So if they give you an example, and then they say, try it yourself. They give you an environment, you run it, and it says, whole world. Okay, it ran it. Cool. Go down to the next thing. It says, oh, wow, test yourself. What's missing? Probably missing print data. But yeah, this is a really cool site. I encourage you to play around with this. It's got the whole list of all the commands, Python comments. I forgot that it was a pound sign. I thought it was // so I could have reminded myself. They've got some examples of how you use comments, which are really good. Variables. All of the stuff that we're talking about here. So if you see something mentioned in the book, or I show you an example of it, you forget, or you want to see more about it, w3schools.com.
So my next question is, how do I save something in Python to turn it in?
In this,
Yeah.
well, you would copy it and paste it over to Thonny.
Okay, and then turn it in?
Yeah, I would. So this is what we call an integrated development environment, an IDE, and the book will talk more about that also. It's integrated, meaning it has your editor, it has your Python compiler, it has your debugging and testing environment, it shows your output, the whole thing, it's all integrated. This is just a Windows console prompt that you can run your stuff with. So, exit, quit, Control Z. There we go. So if I go to the desktop, and there's my example.py file, right? So I can type Python space example.py, which was my Python program, and I can run it from here. Please enter first number, 7, 14. And boom, there you go. Yeah, sorry, it's. So it's just not an integrated environment. This is just an environment for running, Python program once you've already written it. I could use something like Notepad to write my program, save it, then come back to here and run the program, go back to it, Notepad, fix my program, come back here, run the program. It's just not integrated. That's all Fawning is doing, is it's combining the two together into one package that kind of makes it nice and has some other features.
Gotcha. Thank you.
Sure.
What I find pretty interesting is like now you can program a notepad too,
Yeah,
for like certain stuff.
yeah,
I play like a video game and like it's a whole sort of game that we put like notepad files that are like programs and it like runs the program. And, like, does stuff in the game.
very cool.
Like it changes stuff, so.
Yeah, in the end, it's just a text editor. What text you put in.
Myself don't know how to do it, like other people that play the game have done it, so.
Yeah.
So-
And YouTube is your friend.
So, why?